Okay, these are a little bit tricky, sort of. You have to pay attention. First of all, we are now talking about definite integrals, where there's going to be a b, an a and a b. A is the lower bound, so if you're looking left to right, a comes before b. This is the lower bound, this is the upper bound. All right, so express each definite integral in terms of u, but do not evaluate. So for right now, you don't have to evaluate, but you do have to be careful. So it tells us what u is. U is 2x squared plus 3. So du is 4x dx. So that makes sense. However, this u right here, see these lower and upper bounds? They have to be plugged. So we're going to do this. Remember, you're just rewriting it in terms of d and u and du. But in order to get our new upper and lower bound, we plug 0 into the u function. 0 squared is 0 times 2 is 0 plus 3. 3 is our new lower bound. We plug 3 into the u function. 3 squared is 9 times 2 is 18 plus 3 is 21. And now, remember the x dx, the 4x dx can be replaced with du. And now what do we have? We have u squared, 1 over u squared, or you could write it as, I should do it this way, u to the negative second. And I'll accept either way, but that's all you're doing for right now. You're just setting it up, but do not evaluate. All right, I'm going to keep going on these. Well, yeah, I'll keep going. Okay, now we are evaluating a definite integral. So when you evaluate a definite integral, there's two ways we can do this. We can see that as one function with separate parts, or we can actually use integration laws and actually do this. We could do the lower and upper bounds, the integral from negative 5 to 1 x dx, and see that subtract sign? Subtract the integral from negative 5 to negative 1, 2 dx. And that's integration laws. Those are two separate pieces, or we can just integrate it as one entire thing. But here's the rule. Once you integrate, you're going to integrate it, and then right here you're going to put this vertical line to remind yourself, oh yeah, but we have to apply the lower and upper bound. And when you do that, you have to do f of b subtract f of a. So when you find the integral, you plug negative 5 into all of the x's, and that's your f of b. Then you subtract, and you plug the negative 1, or the upper bound. So here's your a, here's your b, here's your a. There you go. Into the function, you subtract, and then that, you go ahead and put your value right here. All right, so I'm going to take it like this. Remember, if you have x, the integral to x to the first, add 1. So that's going to be x squared divide 2. Subtract. Well, the integral of 2, that's x to the 0, so add 1, divide 1. That will just be 2x. So now we have our integral, but now we have to do f of b. So we're going to plug negative 1 into this function, and we're going to subtract when we put negative 5. So negative 1 squared is 1, so that's 1/2. Negative 2 times negative 1 is positive 2. So 1/2 plus 2 is 2.5. And or you could put 5/2. And I'll probably want the fractional version and the decimal version. All right, now we're going to plug negative 5 into the function. Well, negative 5 squared is 25, so that's 25 halves. So yeah, let's leave this. Let me undo this. Let's leave this as 5 halves. All right, so that's 25 halves. Subtract. Well, 2 times negative 5 is positive 10. But instead of writing 10, we want those to have the same fraction. So we'd multiply here top and bottom by 2. So that would just be 20 halves. So now what we have is 5 halves subtract 25 plus 20 is 45 halves. 5 subtract 45 is negative 40 halves, which is negative 20. Just like that. All right, I'm going to pause this. Okay, before I go on, a second ago, so we ended up with our answer. I'm not going to put all the work back up here. It was something like this. F of x is equal was x squared over 2 minus 2x from negative 5 to negative 1, and that equaled negative 20. Notice this is now a definite integral. You do not put the uppercase C because we know that we're going from negative 5 to negative 1. We know the actual area. So if you were to draw this graph, that's x subtract 2. So down here at negative 2, then the slope is 1. This is what the graph looks like. And all we care about is from negative 1 to negative 5. So what we care about is maybe that part. All right, now I'll pause again. Okay, this has a fractional exponent, and we're going to bring that 2 out in front. So x to the 1/3 plus 1, which is 3 over 3, that's 4/3. Well, when you divide by 4/3, remember we're going to multiply by the reciprocal because we do not want a fraction. So this is going to be 3/4 x to the 4/3 and then multiplied by 2. So f of x is equal to, let's see, 2 times 3/4 x to the 4/3. Well, that simplifies to 3 halves. So f of x is equal, what do we say? 3 halves x to the 4/3 from negative 7 to negative 3. So we have to do f of b subtract f of a. F of a. So when we put negative 3 into this, well, negative 3 to the 4th power, so negative 3 to the 4th power is 81. And then this denominator 3, that means the cube root of 81. Well, let's see what we have for the cube root of 81. Well, 81 is 3 times 3 times 3 times 3. The cube root of something cubed, a 3 comes out. And now what you have is 3 cube root of 3. And so we have 3 halves here. And I'm going to do it this way to make it easier. I'm going to bring the 3 halves outside of that. So all we're doing is integrating, doing the 4/3, which is what I did a second ago. So this is 3 root 3. Now I'm going to plug a negative 7 in there. Well, negative 7 to the 4th, so in parentheses, negative 7 to the 4th, to the 4th is 2,401. And now we need to do the cube root. So the cube root, remember, this was negative 7 to the 4th. 2,401 is also 7 times 7 times 7 times 7. There's 3 of those. So that is going to be 7 cube root. Whoops, that's a cube root right there. of 7. So inside here, this is 7 times the cube root of 7. And now you have 3 halves where you do the distributive. So let me erase all of this and let's go back to 6th grade math and do the distributive. Well, 3 halves times 3 is, well, both of these are now going to have 2 in the denominator, so I can just put a 2 down there. And then 3 times 3 is 9 times the cube root of 3. Subtract 3 times 7 is 21 times the cube root of 3. So that's what you're going to put right there for your answer. Let me do that a little bit darker so it's 9, a little bit too dark. Cube root of 3, subtract 21, cube root of 7. Because it was the cube root of 2,401, so 7 times 7 times 7 times 7. I was really fixated on that 3. Okay, so even when it's a fractional exponent, this is pretty doable. All right, we'll need to practice this. I'm going to go ahead and stop this video so it doesn't get too long.